I love that picture. The parameters of a probability distribution. Ooh, remember the difference between parameter and statistic? Statistic refers to a what? It's a measurement of a characteristic of a sample, and a parameter is a measurement of a population. So that's why we're using mu for the mean here and sigma for the standard deviation. Ooh, remind me what sigma squared is? The variance. Good. This is the population mean, population variance, population standard deviation. I just wanted to show you how ugly those formulas were to make you give your calculator a hug before you go to bed tonight. We're not going to do any of that by hand. This is how those formulas make me feel. Let's talk about how to find the mean, the variance, and the standard deviation for a probability distribution. This probability distribution is a group of 5 babies are randomly selected. Going to run in the nursery and grab 5 babies. What are the possible answers to the question, how many of those babies have green eyes? I grab 5 babies. What are the possible answers? 5 or 0 or 1 or 2 or, yeah, 0, 1, 2, 3, 4, or 5. Those are the only answers that make sense to that question. If I grab 5 babies and say, how many of them have green eyes? Either none of them do, or all of them do, or something in between none and all of them do. Now, green eyes are kind of rare. So this gives the probability of no babies having green eyes. I could grab 5 babies, and there's more than a 50% chance that none of them are going to have green eyes, because green eyes are kind of rare. There's about a 36% chance that only one of them would have a green eyes, about a 10% chance that 2 of them would. The chances that 3, 4, or 5 of the babies would have green eyes is very, very low. It would be very odd if you just went in a hospital, grabbed 5 babies, and all 5 of them had green eyes. That's a shocking phenomenon. That's what this 0 with the little plus beside it means. You can't say that it's technically impossible for all 5 babies to have green eyes. It's not impossible, but it's very, 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 very unlikely. And that's what 0 with a plus beside it means. Almost 0. All right, so we want, number 1, is this a probability distribution? What 2 criteria have to be met in order to say, yes, this is a probability distribution? 2 things. All these probabilities have to add up to 1. We could punch them on the calculator real quickly and make sure that they do, but they do. What's the other criteria? I'm sorry. No. They all have to add up to 1. And what about each individual probability? It has to be between 0 and 1. And that is true as well. So yes, this is a probability distribution. So without using those horrendous formulas, I'm going to show you how to find the mean of that probability distribution and the standard deviation of that probability distribution. This mean would tell you how many green-eyed babies to expect if you grabbed 5. If I went to every hospital in the country and grabbed 5 babies, then what would be the average number of babies with green eyes if I grabbed whole bunches of groups of 5 babies? Well, we put the X's and the probability into the calculator in 2 lists. You can put your number of babies with green eyes in list 1 and the probability for each one of those values in list 2. Go ahead and do that. Go to Stat Editor and make list 1 be the X values and list 2 be the probability values. Did you forget yours? I wish I had an extra to hand you. I don't. Yes, for the last one, you don't have to enter the plus. Just say that the probability for 5 babies with green eyes is just 0. Take me just a minute to catch up with you. Yes, because it's practically 0 and you don't have to enter that 0. 0.528, 0.360, 0.098, 0.013, 0.001, and 0. Is anybody missing any of their list and forgot how to put one back? When you first press the stat button, number 5 is stat editor. It puts all your lists back. Just hit number 5 and then enter, and it'll say, okay, all your lists are back now. Technically, it doesn't matter which list you use as long as you remember the name of which 2 lists you use. Now, does order matter here? Would it matter if I had these numbers in a different order? These are probabilities for specifically this number of babies with green eyes, this number of babies with green eyes. So as long as I kept the 0.528 with the 0 and the 0.36 with the 1, it wouldn't matter what order I put the ordered pairs in, but my probabilities do have to match up with each possible outcome. All right, what do I have next? Quit your stat editor. Just a second and quit to get out of there. And then press stat. Move the arrow over one place, and number 1 will say OneVer stats. That's what we're going for. Stat, move the cursor over 1, and then choose number 1. One thing that several people left blank on their study guides, maybe it was just because I had it in small print and you didn't notice, but on the study guide I had where to find standard deviation on the calculator and where to find variance on the calculator, because we're going to learn to do so many more things with the calculator. It's good to have on your study guide, hey, where did we find that OneVer stats? Or I don't remember where to go on my calculator to find the mean of a probability distribution. So you'll see on the study guide, I have a place for write down the steps you punch on the calculator in order to find the mean and the standard deviation of a probability distribution. Yes, ma'am. Can let me show your calculator. Calculators are just like computers, and I didn't know this till a couple of semesters ago, but just like computers and your iPad and your iPhone have updates, they make updates for TI-83s as well. And some of us have, I don't even know which one is more recent, mine or yours, but let me show you what some of these calculators are saying instead of what mine says, and this is absolutely fine. Usually comes in just a second. There we go. So if that's what your calculator is saying, that's absolutely fine. Can I get more? If this is what's showing up on your calculator, you say, I put my X values in list 1. These frequencies They're not actually frequencies. The calculator doesn't know that you've entered probabilities, but you tell it, I've put my frequencies in list 2, and then press calculate, and you'll get the same thing I'm fixing to get. So Miss Ashley, when I hand this back to you, just make sure you have list 1 here, list 2 there, and press calculate, and you'll get the same thing I do. That's going to happen several times this semester. It's just a different way of entering the information, but it works the same way. All right, for those of you whose calculator did what mine did, just popped up one variable stats, I need to tell the calculator I put that data in list 1 and list 2. And remember, to access those lists, you have to press second list 1, second list 2. Everybody look up a second. There's one other thing you need to know. If your calculator looks like mine, you're going to have to use your comma button. Your comma is right there over number 7. You're going to enter list 1 and then comma and list 2. List 1, comma, list 2, and enter. Now, regardless of which operating system you have, did everybody get this same mean and other stuff? I'm sorry, what? Error? I know what that most likely is. Go back to your, let's see if it'll tell us. No, let's go back and see if maybe, usually when that happens, you've entered more numbers in one list than you have the other. So it could just be a typo in your stat editor. Yep. You left 0 out of the top. So you need to retype list 1. That's something to watch for. When you get an error like that, though, you may not have the same number of entries in both lists. All right. Like I said a minute ago, my calculator has no way of knowing that these are probabilities. The calculator thinks they're just frequencies. Thinks this is a frequency table where the possible outcomes are 0 to 5, and here's how many times a 0 happened and how many times a 1 happened. So the calculator is going to give me the results X bar, like that's the mean of this sample. Well, we know that that's a a probability distribution for a population. And so that's why we're going to write our answer using mu instead of X bar. We're going to write, yes, it is a probability distribution. Its mean is this 0.599, but it's mu instead of X bar. And trying to think if it told us what to round to. It didn't. Let's stick with three digits there. My math lab would tell us 0.599. And what is the standard deviation for this data? Here's where you have to know your symbols. You have to know which one of those things means standard deviation. And it's sigma that means standard deviation. So if we round it to 3 decimal places, it's going to be 0.725. The one other thing you notice at the bottom of my results screen here, it said n equals 1. Again, because the calculator thinks these are frequencies, it's telling me what all the frequencies add up to. If this is indeed a probability distribution, what should all these add up to? 1? It did. So I don't have to type in each frequency, add them up, and make sure they equal 1. The calculator is going to add them up for me. But because of rounding errors, sometimes that can be off just a tiny bit. It could be 0.999 or 1.001. That's close enough. It's just the fact that these are rounded that might cause them not to be exactly 1 sometime.